Hello, Econ 2. This is the Chapter 22 homework help. Chapter 22 deals with the decisions of an individual firm, a firm in a perfectly competitive marketplace, and this is going to follow closely on what we talked about in Chapter 21 with the costs of a firm. So you'll see that we put it all into action here in this chapter. Hopefully you have already reviewed the chapter, the PowerPoint, you have a solid understanding of the concepts, and you use the homework for practice. So number 1 gives you some details about a news story, and they ask you a couple of questions from the story. So even though they don't give you the answers directly, as astute students, I'm sure you can look at this and do some calculations. For example, how many fish did Farmer Hollingsworth had? Well, he had 10 ponds, each holding 100,000 fish. So you've got that information. If each fish weighed 2 pounds, what percent of the market did he have? Well, you've got 100,000 times 10, which is 1,000,000 fish. If each fish weighs 2 pounds, then you've got 2 million pounds of fish. And the question becomes then, 2 million is what portion of the total? And you've got to find the total here. And if you do the calculations, you can say he takes about 60,000 weight, and they give you the number of 340 million pounds this year. So that's the total. So you ask yourself, what does 2 million out of 340 million represent? And it's just a ratio. So you want to know what percent 2 million represents of the total. You do a simple division problem, multiply the result by 100, make it a percentage, and there you go. The second one is asking you to recognize explicit and implicit costs. This is a bit of a repeat from the last chapter, but it's an important concept because for the competitive firm, making decisions doesn't just involve the explicit costs. The implicit costs of opportunity costs are an important part of how costs are calculated so that they get the most accurate information. So for number 2, it says, if the owner of the drugstore hired a manager for $10 an hour to take his place, how much of a charge would show up in his accounting profits and his economic profits? Well, we know that the wages of the manager, I should say, are $3,000 a month. That's what they pay themselves. So if instead of paying themselves, it becomes not an implicit cost because that $3,000 represents what they would be doing with their human capital, now they turn that into an explicit cost because they're going to pay an outside party $10. So that $3,000 becomes now an explicit cost. So that's going to change accounting profits. It's going to change those by $3,000. And it's not going to change economic profits because economic profits was already total revenue minus implicit and explicit costs. So moving something from one category to another, if you're subtracting them both, won't have an effect. So you can see that one pretty easily and work through it. There is another one that looks similar to that, and you're going to get that on an algorithm basis. So just use those same concepts to work through that one. Number 4, you've seen before, Kanisha is an entrepreneur, and it just asks you to recognize her accounting and economic profits. And as a reminder, because I know you already know this, accounting profit is revenue minus explicit costs, those things that you get a receipt for, and economic profit is revenue minus all costs, so explicit and implicit, which are those opportunity costs we look at. So in this case, you should be able to easily calculate her total explicit costs and her explicit plus implicit costs. Number 5 is starting the process of seeing how graphically this reveals itself. So we've got some questions to answer from this table. This is the cost curve, the marginal cost curve for the firm. And it asks us to look at the information here. So we've got the number of bushels per day, and you can see that here on the horizontal axis. The price that it's sold for, the total revenue, the total cost, the total profit, the marginal revenue, marginal cost. So this curve represents the marginal cost. So this is a relationship between number of bushels per day and marginal cost. So that's what we see graphed here. The question says if the price of catfish fell from $13 to $7 per bushel, then what becomes the profit maximizing output, and what is the profit or loss per bushel. So if it goes to $7 per bushel, that's marginal revenue, right? Each bushel sells for $7. So the profit maximizing output formula, and hopefully you saw this and you internalize this because this is a really important concept to understand about the decision making of a firm, is MR, marginal revenue, equal to MC. As long as marginal revenue is greater than marginal cost, you should continue doing it. At the point where marginal revenue is equal to marginal cost, that's the maximizing point. And then if you get to a point where marginal revenue exceeds marginal cost, you would not make that decision because it's not adding to your total revenue. So this is what we're looking for. MR equal to MC is the profit maximizing output decision. So that's how a firm decides how much to produce. They look at the point where marginal cost is equal to marginal revenue, and they say that's the profit maximizing output. Or in the case of a loss, it's the loss minimizing output. So $7 per bushel, we would look for the point where marginal cost equals marginal revenue. Well, here's marginal cost, and we just said if the marginal revenue, $7 per pair, is what's coming in, then that's our balancing point. 7 equals 7, and the output is 2. And so they had before in this column, it's a little tricky because they fool you a little bit by saying, well, it was 13 originally, but they give us that new number. So we can find that pretty easily. And then what's the profit or loss per bushel? Well, and again, we can figure this out too. We can say total cost, or we can look at marginal cost. So if marginal cost is equal to, is equal to $7 for both of those, we look at the total cost of producing those 2 bushels, and we've got $22. So 2 bushels cost $22 to produce. We take in $14 of revenue. Marginal revenue is $7 each. So 22 minus 14 is going to give us 8. So the profit or loss per bushel then is 8 divided by 2 because that's a total loss. So it's going to be -4 to indicate a loss. So that's where I got that information. And then total profit or loss is that 8 that I came up with originally. Again, if you see this as a different numbered problem, right, if it's an algorithm and you have different numbers, don't be concerned. It's a good way to learn. In fact, if you come across this one and you say, okay, I worked through that, and there's no risk to you to try the second and third versions of it. Go through it again and again. Practicing this can only make you more comfortable with it and make it easier for you. This really is complex stuff and unfamiliar stuff for most people too. All right, number 7, we're back to those costs of a firm. So this says complete the following cost and revenue schedules for a perfectly competitive firm. And we're going to take the quantity times price to get total revenue. And so I'm going to let you work through these numbers, but I'll give you just a few to get you started. 0 sold means 0 revenue. And so 1 sold is $50 revenue, 2 sold at $50 each is $100, and so on. So that becomes easy. Total cost is, you've got, they're looking for marginal cost. So marginal cost, reminder of that, how we calculate that, is the change in total cost divided by the change in output. And since, in this case, the change in output is always 1, it's going to just be the change in total cost. So we can go 50 to 60, marginal cost then is 10. 60 to 90, marginal cost is 30. 90 to 140, marginal cost is 50, and so on. So that part, pretty manageable. Then they ask us to graph the marginal cost. So we're going to take quantity on the horizontal axis and our marginal cost information on the vertical axis, and we're going to put that into a graph. And we're going to get something, and I'm just drawing a line here, so don't think that I've plotted any points, but you're going to get something approximately like that. C asks us to find that maximizing output decision, and that is MR equal MC. Well, they've told us that the marginal revenue, the price, is $50. So the question is, where does marginal cost equal $50? Well, you've already seen it in the chart here. So it should show up on your graph, And I may have accidentally graphed it right. Look at that, I just kind of magically did, but didn't mean to. But you can also see that in the chart that at $50, equal to $50 is right here at 3 units of output. So you're going to see is that profit maximizing output decision graphically is where MR equals MC. If this is my marginal cost curve and it's my marginal revenue curve. So that's the rate of output that maximizes profit, and the rate of output is 3. Watch out that you're using the correct units there. And what is marginal cost at that rate of output? And we already said it's $50. So again, instead of just taking my word for it, always work through the numbers on your own. You never know if yours is different than mine and you're just not seeing that. So I encourage you to work through it. Make sure you totally understand what you're doing as you're doing it. Number 9, again, with those costs, now we're going to add in per unit costs. And this is probably something that's still new to you, even though we saw it in the last chapter. We're going to assume that the price of the product is $5. What that piece of information is marginal revenue. Marginal revenue is $5. For every unit I sell, I bring in $5 if I'm a perfectly competitive firm. So using that information, I'm going to complete the table. And you've got the price, $5 right here. So I'm going to calculate my marginal cost, which I'll remind you again, marginal cost is equal to the change in total cost divided by the change in output. And you can see that the change in output is always 1. So that's not going to be an issue. We're just going to really calculate the change in total cost. And then we'll do average total cost, profit per unit. So let's start with marginal cost. Marginal cost is the change in total cost. So from 3 to 4, marginal cost is $1. From 4 to 6, it's $2. From 6 to 10, 4. 10 to 16, it's 6. 16 to 24, it is 8. So we take that and we can calculate average total cost by taking total cost, which is in the column right here. Total cost divided by the quantity output, that's a Q. And so we can start working through that. And total cost of 4 divided by 1 is 4, or average total cost, I should say. Total cost of 6 divided by 2 gives us average total cost of 3. And so on and so forth. And I think you can see this. Sorry about that. Average total cost is 2, 4, 3. Sorry about this. I'm trying to see this clearly. Continuing on. Total cost of 10 divided by 3, 3.33, and so on. So average total cost, just to remind you, is total cost divided by quantity of output. So from there, we can calculate the profit. Profit is revenue minus cost. So we'll do total revenue minus total cost to get total profit. So we've got total revenue at each level. Total revenue is $5. Total cost is $4. So in this column, we've got profit of $1. I have to go through all this right along with you. Total revenue of 10 minus cost of 6, 4, 15 minus 10, 5, and so on. And then profit per unit is simply, and by the way, this is if you have 0 revenue and $3 of cost, you've got a -3 there. And so the profit per unit is simply taking that total profit divided by the number of units of output. And again, it becomes really easy, 1 to 1 by 1. 4 divided by 2, 5 divided by 3, and so on. And if they ask for it in decimals, you can just do 5 divided by 3 on your calculator. All of that's really easy to do. So where is total revenue maximized? And you'll be able to see. And you can actually look at it right here in the chart. Where's total revenue maximized, where we get the most revenue, and it is right here. Where's ATC minimized? And you'll be able to look at your average total cost and see the point where it is at its minimum. Profit per unit maximized, and you're just looking for the point where it's at its highest. And total profit maximized. You're looking for its point where MR says hint use a profit maximization rule. MR equals MC. Right? So that's the profit maximizing output decision. And they're asking for that in units. So they're looking for the profit maximizing output there. All right. I think you'll do okay with that one. Number 11 is a little bit more calculating. In fact, this one, what you're going to want to do is you're going to work through all of the different values connected with this. So this one actually has a lot more to it than you see here. And this is where you, as a student, will just get the hang of calculating all the different parts that go with it. So here, they ask you the profit maximizing rate of output, which is MR equals MC. So you're going to have to calculate your marginal cost from all the data you're given above, and how much profit at that rate of output can be earned. So we can go, we've got total cost, we've got quantity, so we've got total revenue, we can calculate that, and we can do marginal revenue from that. We can do marginal cost, so marginal revenue. Actually, we've already got the marginal revenue because that's given to us as $21. So we'll call this marginal cost. If you feel like you want to have a marginal revenue column in there, go for it. But it's given to us, so we don't really have to do too much with that. Let's go marginal cost. We want our average variable cost. We want our total revenue. And we want our profit. And I'm just going to use that symbol for profit. And I think we can work from here. So let's see where we are. I want to make sure these numbers match up what I had. Okay, good. So let's just run through a few of these to get the hang of it. And I think all you have to do is set it up properly, and then the calculations start to get pretty familiar. So total revenue is price times quantity. So here we've got 0. You might set this up in an Excel sheet, whatever works best for you. A graph paper, if that works for you too. 2 times 26, so 52. And so on. So total revenue, 52. Look at that. My math, I made a mistake in my math. And so on and so forth. Marginal cost is the change in total cost divided by the change in output, which is always 1. So it's going to be the change in total cost. So there's no marginal cost for that first unit, or 0 units rather. But for the first unit, it goes from 10 to 17, so 7. 17 to 26, 9, and so on and so forth. Average variable cost is going to be the difference between fixed cost and variable cost, and total cost. So this throws people because they're like, where is the variable cost? So what you can do is you can set up a column for variable cost if you want. That might help you see it more clearly. Variable cost is total minus fixed cost. Well, we've got total cost right here. And our fixed cost, here's how we can tell our fixed cost. At 0 units of output, it cost me $10 to produce it. Therefore, I know that my fixed cost must be $10 because there's no variables involved. If I'm producing 0 units of output, I'm not engaged in anything that would require variable cost. So my total cost minus fixed cost. So at every stage, my variable cost is my total minus 10. Hope that makes sense. So total cost minus 10 is 0 variable cost for that 0 units. For that first unit, well, if 10 is my fixed cost, then my variable cost for that first unit must have been 7. For the second unit, if my total cost is 26 and my variables are 10, or my fixed is 10, gotta say that right, it's 16, and so on. Okay, then from there I can get my average variable cost. I'm going to take my variable cost divided by my units of output, and there's my average. Profit is total revenue minus total costs. Well, you're going to have total revenue here, and you got total costs here. So your profit. And then profit per unit, I believe they asked that as well. I don't believe they do. They just look for the profit maximizing rate of output. So they're looking for MR equals MC. And remember, marginal revenue is 21. So you're looking at a point where your marginal cost is 21, and that's going to be your quantity output that is profit maximizing. And then how much profit earned will be the total profit at that rate of output. I'll let you work through that one, and you have the ability to check your answer and do some things. So you should do okay. just give it a try. Run through the numbers. The numbers can get frustrating. Find a way that works for you. Maybe something like a spreadsheet is better. Perhaps you just like to work neatly on paper. Whichever way works best is going to be just fine. All right, this one asks us to identify the per unit cost curves and to see what happens to those curves, how they shift in the event that conditions in the market change. So this is a producer, the market, not the market, excuse me. This is not the market, this is the individual producer within the perfectly competitive market. And these are the cost curves that they face as a producer. So this is their marginal revenue, is how much they're taking in for each unit they sell. This is their average total cost. And from the materials, hopefully you read about why it decreases at first and then increases over units of production. And then our marginal cost curve, and again, it decreases at first and then experiences diminishing marginal returns and increases over units of production. Not necessarily time. We always say units of production because we're talking about as output increases. So if higher feed prices happen, what's going to happen to the average total cost? And what you should see is that average feed prices are going to contribute to average total cost because they are going to be variable costs. So total cost is variable cost plus fixed cost. Average total cost is average variable cost plus average fixed cost. So if my variable cost, I'm assuming that I've got to feed my fish. That's going to be a variable cost of doing business. So if my average variable cost goes up, then my average total goes up because that's part of it. So I'm going to have an increase there. What's going to happen to my marginal cost? Well, it's also going to increase my marginal cost because it's the change in total cost, right? So total cost is going up. The change in total cost will increase, and so my marginal cost will increase as well. Ugh. Bad. Lower wage rates, and I think you can go through this and use logic for a lot of this, but if it's lowering my total costs, then you're going to have the opposite effect. My total cost will go down, my marginal cost will go down. Higher worker productivity, that's going to lower my total cost because I'm getting more out of the workers I have. Therefore, my average total cost, which is just my per unit total cost, those will go down. Marginal costs will also decrease. And then for D, they ask you, does the profit maximizing rate of output increase, decrease, or stay the same with higher feed prices, etc.? Well, remember, profit maximizing is MR equal to MC. So the higher feed prices, if it raises marginal cost, right, that means that marginal revenue, in order to maintain the same output point, would have to rise as well. But we don't assume that. We assume that only the marginal cost curve is affected. And it's going to shift leftward. So let me show you on the graph what I'm talking about. So if there's an increase in marginal costs, here's what it looks like. I'll just kind of put that there. And notice what happens to the output, the profit maximizing output. Before, MR equals MC is here. Now, MR equals MC is at a lower quantity output. So if in doubt, I always advise looking at it graphically to help understand these things. So in this case, the profit maximizing output will fall. And you can use the same logic with lower wage rates. If lower wage rates are going to bring down my marginal costs, let me use a different color for this one, then here's my marginal cost curve 3, and MR equals MC, and this is going to bring my quantity up. So keep that in mind. And then higher worker productivity will have the same connection. I'll let you work through that one. I'm sure you're not having any trouble. Let's see, where are we? Number 14 is another calculation problem where you're going to run through the numbers of it. And we're going to do marginal cost, average total cost, average variable cost. And this again is going to ask you for average variable cost without necessarily giving you variable costs. So this is where you're going to use your detective skills, and you're going to figure out that variable cost is the difference between total cost and fixed cost. And again, fixed cost isn't given to you, but you can figure it out. If at zero level of output, my cost is $100, that means my fixed cost is always $100. So my variable cost will always be, and I'm so sorry about the mess here, my variable cost is always going to be my total cost minus that $100. And then from there, you can do the average variable cost. So let me just run through a few of these numbers for you. If I have an output of 5, now watch out for this one because marginal cost is the change in total cost divided by the change in output. And every other time the change has always been 1. Well, it's not anymore. Now the change is 5. So watch out for that. That's going to be a little bit tricky. So my total cost is, the change is 10, 100 to 110. But the change in output is 5. So I'm going to go change in total cost, and that is 10. Change in output is 5. So for my first 5 units, marginal cost is 2. So you got to watch out for that one. Then change in total cost, 110 to 130 is 20, divided by the change in output, which is 5 again, and you're going to get 4. So watch out on this one. This one is going to trip you up just a little bit, but just use that same method and you'll be fine. Now that we know our fixed cost, we can always find our variable cost. So I'll just run through a little bit of that with you. Our variable cost, to add this in there to make it easier, is our total cost minus that 100 in fixed costs. So our variable costs for those first 5 units are $10. For the next 5 units, they are 20 minus, sorry, it's total cost 130. I'm so distracted right now. I'm so sorry about that. 130 minus the 100, so variable costs are 30, and so on. To get the average total cost, you'll take total cost divided by units of output. And again, watch out because it's not always change of 1. And to get average variable cost, you're going to take your variable cost divided by the change in output, or by the total output, excuse me, not the change. That's marginal. Okay, so watch out for this one, and the numbers aren't too bad. It's just make sure you know how to calculate that marginal cost, and make sure you identify your fixed costs and variables. That way it's easy to do your average fixed and average variable and average total. You don't need to average fixed on this. And then they tell you if the price is $10, so MR equals MC. So they've told you that the marginal revenue is $10. So you're going to look for a marginal cost level at $10. And how many units of output is that? How much profit or loss? Well, that's going to be your total revenue at that level of output minus your total costs. And the shutdown rule is something you should have read about. It says at what price will the firm shut down? The shutdown rule is minimum AVC. So that's why they want you to gather this piece of information. Minimum average variable cost tells you at what point the firm is no longer covering their variable costs of production for each unit, and that is their shutdown price. They're better off shutting down at that price than they are continuing to absorb the losses and hoping for better times. So this one, I think you can work through these numbers pretty well. It's not so bad. Number 15. This is another one with the calculations, and the firm has leased plant and equipment to produce video games. They are sold at $13 each, so there's your marginal revenue. The following figure gives you the cost of production, and they're going to ask you about fixed costs. Now, this is organized differently, but you can set this up in whatever way you want. You've got your rate of output here on the top row, your total cost per day, and we can see fixed costs are pretty easy to identify. If I produce 0 and it still costs me $50 in total cost, that means my fixed cost must be 50. The profit maximizing rate of output is MR equals to MC, so it's wherever marginal costs are $13. And you're going to do your calculations. Marginal cost is going to be total cost divided change in total cost divided by the change in output, which in this case is simple because it's always 1. And so you can find your profit maximizing rate of output pretty easily. Calculate your profits or losses. You're going to take your total revenue minus your total costs at this profit maximizing level, whatever that happens to be. And how much is lost if the firm shuts down? You can calculate that because, and it says do not include a negative sign. So you're just going to give the number in absolute terms, how much is lost, if the firm shuts down. So at minimum AVC, that's the shutdown price. So you're going to do all of those calculations, find minimum average variable cost, and you can calculate how much is lost if they produce at that shutdown price, or that rate where that's the shutdown price. And then finally, should they produce or shut down? If they are able to take in revenue above, so let me just put it in these terms. If that minimum AVC is, let me say this correctly, is $13 or more, they should stay in business. They're covering their variables. If their minimum, or excuse me, if the revenue is less than this value, whatever it turns out to be, then they should shut down. So the shutdown rule is if the revenue or the marginal revenue, the price they're receiving in the market, is less than their variable costs per unit, they got to get out of business, because between the variable and the total cost is the fixed cost. If they're not taking enough in to at least offset some of their fixed costs, then they're better off shutting down, losing all of their fixed cost investment, and walking away. So that's the logic of that. And hopefully you saw that in the PowerPoint. That's kind of a tough point to absorb. So make sure you run through that, see it graphically, ask me questions if you're still having a little trouble with that one. And then the last one here is a quick look at a very similar information, right? We've got the price of ties of $21. That's marginal revenue. You've got your total cost. We can do our marginal cost pretty easily here. So you can, marginal is the change in total. In this case, it's just going to be the change in total because the change in quantity is always 1. So no marginal cost there. 7, 9, 11, 13, and so on. Let's see, it's 21. Let's see how much further I can go. 37, 50, 50, 65 is 15. 65 to 82 is 17. 82 to 101 is 19. And 101 to 122 is 21. Now I've drawn this way off kilter, but what you can see is the profit maximizing output is going to be where MR, marginal revenue of 21, is equal to marginal cost of 21. It says the profit tax was decreased from 35% to 21%. So they're asking you to do the calculation here. It says determine the impact on marginal costs and identify if the number of ties the producer would supply would change when. So given these different situations, if the profit tax changes, this doesn't affect marginal costs. Marginal costs are per unit costs of production. A profit tax is a lump sum cost that is assessed on the actual profits. So no change to marginal costs if that happens. No change to profit maximizing output because it affects neither marginal cost nor marginal revenue. And then B says, again, we're going to ask ourselves what would happen if the payroll tax is decreased from 13 to 10%. Now that's different. Payroll tax is going to affect the cost of production, particularly the payroll costs, right? So it's going to decrease marginal cost because part of my total cost figure is the cost of my employees and the payroll tax I pay as the employer. So it's going to lower marginal costs. And what's that going to mean for profit maximizing output? Again, draw the picture if you're not sure what that looks like. Here's the marginal revenue. Here's marginal cost 1. Here's marginal cost 2. It lowers it. So what happens to the profit maximizing output? Well, here's the original. And then with the curve lowered, with the cost lowered, we can see that the profit maximizing output increases. And then with C, if a tax of $1 per tie were collected from the producer, and again, this is a cost, a per unit cost of doing business. So the tax is for every unit produced, and the producer, who we're talking about here, is required to pay that tax. So what would that do? Well, that would raise marginal costs, because each additional unit I produce is going to have that tax attached to it. And what's that going to do to my profit maximizing output? Well, it's going to take it here, because here's my higher costs in place. I'll call that 3. And here's my new profit maximizing output. And as you can see, it decreases it. So output decreases. That one's a little bit tricky, but I think if you just use the graphical understanding of it, it helps a lot. All right, I think we've got it all. All right, so that's chapter 22 in a nutshell. Let me know if you have any other questions that I can answer procedurally, and I wish you lots of luck with this one.